Welcome, and thank you for joining our webinar, Solving Kibble Quality Challenges, Optimize Extruded Formulas with Functional, Palatable, and Nutritious Ingredients. I'm Roger Gerlach, Director of Global Pet Food Sales for APC. In the webinar, we will discuss the importance of functional ingredients, what factors to take into consideration when formulating for success in dry pet foods, and how functional ingredients can provide kibble formulation benefits. Our presenters today will be Dr. Joy Campbell and Dr. Nathan Fastnager. Dr. Joy Campbell is the Senior Director of Global Technical Services for Pet Food at APC. She received her PhD in Nutritional Sciences from the University of Illinois at Urbana-Champaign and has worked in research and development at APC for more than 20 years. Her focus has been on understanding the actions and uses for functional proteins across multiple applications. Dr. Campbell is the author or co-author of dozens of publications, abstracts, patents, proceedings, and technical publications. Dr. Nathan Fastnager is the president of Dr. Fast Pet Food Consulting, LLC. He earned his PhD in non-ruminant animal nutrition at The Ohio State University and completed a postdoctoral research position focusing on dog and cat nutrition at the University of Illinois, Urbana-Champaign. He has more than 16 years of working experience in several pet food manufacturers in North America, Europe, and Asia. Currently, Dr. Fastnager operates his own consulting company based in the USA, which provides nutritional services that cover all aspects of pet foods and treats, including product development, ingredient development, regulatory compliance, sourcing, and pet food production. At the conclusion of the presentations, there will be time for questions. Please feel free to use the chat feature to send a question. Dr. Campbell, let's start with a discussion on functional ingredients.
Thank you. Appreciate everyone joining the webinar today. Today, I'd like to start off with talking with you about why functional, palatable, and nutritious ingredients are important. Many of you may know plasma and its functionality in wet pet food. It's been used for more than 30 years in the wet application and all these different type of matrix over here. And then as we've looked at this has included like chunks and gravy, loaf, chubs, etc. It's known for its improving the functionality that includes like emulsification, water holding capacity, and gelling, along with it being a palatable, nutritious, and digestible for the animal. And today we're going to cover how our ingredients are not just for wet foods. Plasma has been used in different dry pet foods, such as complete food, treats, and supplements. Below you can see various forms that have utilized plasma, such as dental sticks, complete food, and various treats. Today I want to talk with you about what is plasma. It's high in protein, amino acids, and biologically active components. It's a complex mixture that provides nutritional and health benefits when orally consumed by the animal. The composition of this also provides physical functionality in the animal food processing. Our ingredient of spray-dried plasma, known as AP920, has a crude protein of 78% minimum and an ash of the max of 10%. The typical amino acid profile can be provided in our spec sheets as seen here. You'll notice it's low in fat and it's as a source of minerals, calcium, phosphorus, sodium, and chloride. We also have a typical amino acid profile providing many essential amino acids, and it can be low in the sulfur amino acids of methionine and cysteine to account for things. A recent review paper published by Vasconcelos et al., published in 2023, reviewed spray-dried plasma as a multifaceted ingredient for pet food. The highlights from this paper include multiple benefits and applications of plasma that include a high nutritional standard, technological properties, and health benefits. One of the things brought up in this paper is they talk about the protein digestibility corrected amino acid score. We see in this slide a list of the different ingredients that plasma was compared to, which are ingredients that are utilized in the pet industry. The graph to the right show the amino acids. And what we see here is with plasma is the first bar here in the graphs shows that it's the highest in lysine, tryptophan, and threonine, whether it be for dog or cat. And it is lower in methionine than the others as noted, thus demonstrating the plasma is a quality and digestible and protein ingredient. So when we're thinking about formulation in this, there's different ways to think about it. There's many benefits to be considered. At lower protein levels of the diet, one can use it to extend protein shortages, boost the protein, or potentially reduce costs depending on formulation. As you move up in the higher protein formulations the needs, you can use it along with to get more animal protein into the formulation rather than plant proteins. And it can help with reducing the ash, calcium, or salt from the formula, since it is also lower in ash and does provide calcium and sodium. Lastly, it's also known to improve palatability compared to plant proteins, which we'll cover a bit later. So when we think about this, thus the importance of the palatability and boosting animal proteins, plasma can be a great option that is low in ash, it's high in protein. It helps to balance that. It mentions the calcium and phosphorus from meat meals, as it's low in the calcium and higher in the phosphorus, and it's good for the high protein foods. Now I'd like to move into palatability for dogs. We've demonstrated improved palatability versus pea protein. It can also be used to replace other proteins, such as dried egg, along with providing functional benefits of support for immune and digestive health. So as we look at dog palatability, to understand this, we first did a comparison of 5% pea versus 5% plasma. Here we see a graph shows the intake up with the plasma diet compared to pea protein, demonstrating improved palatability. These diets were formulated to 28% protein. We also did another diet that was formulated to 32% protein. Again, we were able to replace a portion of the pea protein with the plasma. And again, we saw a higher intake with the diet containing the combination of the plasma and pea protein. Thus, in both cases, the intake was increased when plasma was included in the kibble, indicating improved palatability. Along with looking at palatability, we have also compared it with durability, and this is durability of the diets that were formulated to 28% protein. And what we see here is similar durability across all the different formulas of around 97%. Next, I want to move into palatability for cats. Here we compared to spray-dried liver. Again, we incorporated the plasma into the kibble and not as a coating. We evaluated with various palatants and also altered palatant levels. We were not using it to replace palatants. The other thing to remember also with this product, again, it can provide functional benefits to support immune and digestive health. So let's look at the cat palatability. In the cats, we were comparing 2% poultry liver versus 2% plasma. So similar, and then we had similar levels of palatant on both kibbles. In this first test, we see that we again, with plasma compared to poultry liver, saw an increase in the intake, indicating improved palatability. In the second test, using the same kibbles containing either poultry liver or plasma, we then altered the level of palatant. And in this situation, we lowered the level of palatant on the plasma kibble. Again, in this situation, we did see a nice increase in intake in the plasma-containing kibble. Thus, with both situations, including plasma inside the kibble, improved palatability. Now moving into digestibility. We ran an experiment with digestibility, incorporating the plasma into the kibble with either 0, 1, 2, or 3%. All the diets were extruded and then fed into a dog study in a Latin square design to evaluate digestibility. What we see here is that all levels of plasma increase dry matter and crude protein digestibility. Thus, this digestibility was significantly improved even when plasma was included into the mash prior to extrusion. We evaluated intakes also in the study. Intakes were similar across all treatments, and as expected, we did see a significant reduction in fecal output, similar to what we see with what you would expect with an increase in digestibility. We saw less fecal output. Thus, as we look at this, and we've kind of covered the basic research on plasma. Plasma is a nutritious and functional ingredient that has had consistent results for dogs and cats. It also helps with digestibility, palatability, and product quality. So with that, I'd like to pass it over to Dr. Nathan Faster to share with you about formulating products for success in dry pet food.
Thanks, Joy. I'd like to start out with some trends that we're seeing in dry kibble. And at the end, we'll talk about how plasma can help you enable some of those trends. We're seeing and have been seeing for the last 5 to 10 years, a lot of even lower tier brands starting to use what we call real meat claims, whether it's made with real meat to get you to the flavor approach or made with real meat at the 3% level. We're also seeing some companies in the lower tier use meat first formulation, and it's probably more common now than ever for someone to claim real turkey or real beef or real chicken as the #1 ingredient. Using this approach, you can really, from a formulation standpoint, use either fresh or dried meats. Another trend that we're seeing gain traction has been animal-based protein claims. And whether you're calculating that percent of protein coming from animal ingredients versus plant ingredients, some companies publish exactly the level. Some of them give them an at least 75% or 88%. But the goal is to promote animal protein on the premise that it's better than plant protein, which is typically true from a digestibility and amino acid content point of view. When you're using animal-based protein claims, you can use real meat, fresh meats, and meals to get to your totals for your claims. And then there's another approach or another trend in the really, really high meat movement, right? Where you're trying to make claims based on the animal ingredient content, whether it's 95% or 90% or 65%, in this dry kibble, which is not as easy to do, which is why there's such a competition to get to the highest level. Many brands are trying to do that 80 to 90% meat in the really high ultra premium tier. And keep in mind that all of these numbers are calculated from the pre-processing weight of the meat that you're using. And this can also be done from a production standpoint with both fresh or dried meats. So why are we seeing these types of trends? Well, animal protein has a better amino acid profile than plant protein. And in general, animal protein is more palatable than plant protein. And there's data out there, and a lot of manufacturing and brands understand that fresh meat content improves palatability in kibble. So all reasons to get behind the fresh and more animal protein trends when it comes to the consumer's desire. Now we're going to talk a little bit about extrusion, just to kind of highlight what are the variables that we control so that we can understand where meat goes and how to approach this from a production point of view. This is a generic diagram of an extruder. We have variables such as the dry batch flow rate, the liquid flow rates, the moisture and temperature of the preconditioner with trying to target a specific moisture content of that mash as it enters into the extruder. You can also control the extruder speed, the moisture and temperature of the barrel, whether you're adding steam or water. To each of the steps is kind of up to the manufacturer and the design of the extruder. A back pressure valve, if there is any, to help with expansion. The die shape size obviously impacts the density of the product and the size and shape of the kibble itself. As we think through what we're trying to control for with all of those settings, one of the major goals is starch cook. You want to be at or above 80% starch cook, because if starch cook is lower than that, you can actually cause some stool quality issues in the animal when it gets fed. And those starches that are not hydrated and not cooked are more difficult for the animal to digest, but very easy for the microbes in the large intestine to digest, which is what typically leads to the stool quality issues. You're also trying to control for the density. And the density can be controlled through the kibble shape and thickness, how much air you put into the kibble, which is the texture portion. And why do we look at density? Because it does impact the appearance, the size, the bag fit. So if you have a bag template for a 5 pound of kibble and you have too light a density, it may not fit in that bag. And it also impacts the feeding guidelines because they're measuring it in a cup, and the density of that measuring cup can be different based on how dense the product is. Another production measure that we're keeping an eye on are fines generation. This one is mostly a production cost measurement. If you have broken and or out of spec kibble from variation within the manufacturing process or reduced durability due to some ingredient, that's what the production facility is going to be measuring and keeping track of and trying to find the ways to minimize the fines generation. Another quality measure is the fat and palatant application, where you're targeting even coating, both because it impacts appearance and can impact the feeding performance in the pets. So let's talk a little bit more about meat slurries and how they typically get used in dry kibble. Most traditional single and twin screw extruders are set up to handle up to 15 to 25% fresh meat. And that's based off of the flow rates of the pumps that are designed to pump it in there. There's many different attributes to the facility and actual production equipment that has to be specifically designed to handle certain levels of certain ingredients. And when you're using that 15 to 25% meat in a twin or single screw, most of the moisture from the meat is being cooked off during the drying process. So if you're targeting 25 to 30% moisture in the preconditioning cylinder prior to it going into the extruder barrel, you're not losing much moisture during that time, but you're going to be cooking most of it off during the drying process. There are also specialized extruders, such as the thermal twin screw, that can handle much higher meat content, 40 to 70, even higher percents of fresh meat. And in this system, the moisture reduction is happening during the preconditioning, extrusion, and drying process. So it basically gives you 3 places in which you can cook some of the moisture out of those fresh meats, and that allows for higher fresh meat inclusions. So where do we typically add fresh meat during extrusion? Right, it's typically added into the beginning of the preconditioner, so it would be in the liquid additives step from this diagram. Some of the issues that come up as we utilize fresh meats are the variability of those ingredients. We know that the moisture, protein, and fat can all vary from batch to batch and supplier to supplier. And as you target a specific moisture content in the preconditioner, if you have a a certain amount of steam already being added or water already being added, and now you have a variation in the water content of that meat. When you switch from one tote of meat to another, you can end up having some surging that happens during extrusion, which makes it, a headache for the extruder operator to have to balance that throughout the run. We know that fat can also impact this, but mostly the moisture variation in the extruder really affects the starch gelatinization, and then that impacts the starch cook and the density of the kibble. If we take a look at some examples, this is some data that I've collected over the years for a single supplier of chicken MDM and beef MDM. And I've got on the graph or on the chart moisture, protein, and fat, both the min, max, and average. From that single supplier, we could see up to a 7% swing in moisture and an 8% swing in fat content. And that's for a sample size of 32 samples of chicken and 40 samples of beef. For beef, it was actually even worse. We could get a 10% swing in moisture content or a 10% swing in fat content, right? So as you can see, using some of these fresh meats can add some extra challenges in terms of the variability of those raw materials during production. And we talked about how moisture of the meat content makes the extruder operator have to adjust the additional moisture either up or down to try to target a specific moisture content during the preconditioning step. But the fat is actually just as big of an impact, because fat going into the preconditioner and extruder basically acts as a lubricant. And since the friction is very important in an extruder to providing some of the heat and cooking, anytime you have additional amounts of fat, it starts to impact your starch cook, because the product will be going through without as much friction, and that impacts starch cook. And anytime that you impact starch cook, you're going to be impacting the expansion as it comes out of the die, which impacts the kibble size and shape and density. So there's a couple of different ways to control for variation in the meat. Finding a meat supplier with less variation in moisture and fat content, whether it's the supplier actively sending you the correct lot codes that closer match your spec, or whether they're blending together multiple production lot codes so that you have some way of reducing the lot to lot variation. That's one way. Monitoring the meat moisture before you run the product so that you have an idea of what kind of adjustments may need to be made during production is another approach. Some production facilities have chosen to go away from fresh meat and go use a dried meat approach rather than deal with the potential for variation within the meat supply. And then there's also some additives that we can use, and I think Joy is going to be sharing some data where plasma has been shown to help with some of the high meat content approaches. So with that, I'm going to turn it back over to Joy so that she can go through the study.
Thanks, Nathan. What I'd like to cover with you now, as Nathan mentioned, is how plasma can help in extruded pet food formulas. First, let's talk about the reasons to use plasma in extruded diets. One is if you're wanting to market claims for meat inclusion or plasma. We've also talked previously about plasma's impact on palatability, along with, as Nathan mentioned, fresh meat and palatability. Additionally, is to have better durability and less fines to make a good quality kibble, and we'll share with that today what we've seen by putting plasma into the kibble and how it helps with durability. And then finally, the ingredient deck order, the fresh meat, first moving it up. We completed a series of tests at the Winger extrusion testing facility. We utilized both the twin screw extruder pictured here and also their single screw extruder. We were testing the ability to increase fresh meat using the chicken meats type slurry pictured here. So in these studies, our goal was to increase the fresh meat in extruded diets utilizing plasma. As we said, we completed these in both the single and twin screw extrusion, and we were formulating either 2.5 or 5% plasma for the final kibble and looking at various meat feed rates to evaluate the quality of the kibble after extrusion in both dog and cat kibbles. So the first test I want to share with you is on the single screw. We were testing a single screw for a grain-free cat kibble diet. With the control, we had both a 25% or 35% meat feed rate. This relates to either an 18 or 23% fresh meat in the final kibble. We were able to move the fresh meat up with the control up to the 23%, which is that 35% feed rate. But you see what happens as we did that, going from the 18% in the final kibble to 23%, the durability decreased. We then were able to move the fresh meat up with the plasma. We took it up again to that 35% feed rate, 23% in the final kibble. And with 2.5% plasma, we were able to see the increase in durability. We did this with both the 2.5 or the 5% in the final kibble. We then tested in the same formula at the twin screw. And again, as the meat was increased with the control kibble with no plasma, we see that durability was decreased, similar to what we saw in the twin screw. And again, as we then took the higher meat up from the control of going from a 25% feed rate to 35% and including either 2.5 or 5% plasma formulated into the kibble, the durability again was increased like the control with the lower meat inclusion. Along with this, seeing the improvement in durability, we also tested palatability. We were able to make enough kibble, and looking at this in our first test, the comparison was between 35% meat control, which was our control that had 18% in the final kibble, 23% in the final kibble, and then containing either 2.5 or 5% plasma with the same level of meat at the 35% feed rate. In the first graph, we see the 2.5%, and we see an increase in intake. We also tested the 5%, and here again, we also see a further improvement. So again, both of them seeing a nice improvement in the cats. We've got good durability, improvement in palatability of 2.5, and a bit up higher with the 5%. We then moved on to the next study was done with grain diets in dogs. We tested again first on the single screw with our control at a 25% meat feed rate again, which is 18% in the final kibble. Again, durability was good. We do not have a control with the higher meat since we had previously not been able to make a good kibble with the higher meat without plasma. Thus, we don't have this control. We then formulated the plasma in again at either 2.5 or 5% to increase the fresh meat rate. This time, the fresh meat rate was taken up to 45% feed rate, which is about 28% in the final kibble. As you see again, durability for both levels of plasma was good on the single screw. We did like we did before and tested again the same formulas on the twin screw. With our control kibble at 25% meat feed rate, durability was around 90%. Then again, when including either the 2.5 or 5% plasma in the kibble, and the higher meat feed rates up to the 45% feed rate again. Durability was maintained like what was reported we saw with the single screw. So again, a similar pattern between both the twin and the single screw, and improving the durability as we were taking up the fresh meat. We did the same thing again in this situation of testing moving into palatability. This time the control is the 25% meat control. As we mentioned, we didn't have one that we could take the meat up. So our first one, we've got the 25% meat control versus the 2.5% plasma. And again, it is higher meat and plasma compared to meat, so it is confounded, as Nathan mentioned. Higher meat can also help with palatability, but both together we see a very strong improvement in palatability. And also with the 5%, again, having a nice improvement in palatability. Again, demonstrating the improved palatability with fresh meat and plasma compared to the lower meat inclusion. So thus, from these studies, we concluded that plasma included in the formula allows for higher meat inclusion in the diets. Cook and durability were either maintained or improved. And palatability was improved in both the cat and the dog kibbles. So in summary for today, we've talked about the high meat trends are here. We've talked about the extruded pet food is both, kind of an art and science, and the different challenges that happen when you're dealing with the extruded diets. Plasma could be used as a tool to help overcome the challenges of formulation due to the different benefits of protein content, palatability, digestibility, and durability. Again, thank you for joining us. Appreciate your time. We'd like to ask you if you have any questions. Hi, again, thanks for everybody for joining. We'll open it up for questions and answers now. If we could, we'll go ahead and start with some of the questions. I'm going to throw this one for you, Nathan. One of the first questions here is, a diet containing 40% starch gelatinized at 80% equals about an 8% of uncooked starch, while a diet containing 15% starch, only gelatinized at 60, would be about a 4.5, which is still better than the other one. Would it be better to talk about uncooked starch content rather than gelatinization rate?
Thanks, Joy. I would say that both are an appropriate way to review starch cook and how much uncooked starch is there. For the study that we went through, the starch levels were relatively similar, so I don't think that we need to be looking at an uncooked starch rather than looking at starch cook as a percent. In something that is lower in starch, like 15%, even with that low of a starch cook, I do still think you're going to have some stool quality issues, because there still is a significant amount of uncooked starch that's going to be easily digested in that large intestine, which is going to cause some stool quality problems. Maybe not in every dog, but especially in those that are sensitive.
Okay. Thank you, Nathan. Another question that came in is, will you be sharing a copy of the presentation? And I'll grab that. What we'll be doing is we'll be sending out a video of the webinar, not a presentation, but with attending, you should be able to get a link to the video of the webinar for reference. Another question for you, Nathan, is, how do pet manufacturers determine their claim for meat?
So all of the math is done based on how they weigh the ingredients out for the recipe. So if you're using a fresh meat that's 75% moisture and you're putting 1,000 pounds into a batch, you're going to be doing it on the pre-processing weight of the ingredients that are weighed out to make the recipe. So, the other example is, if you're using a dried meat, then you don't have the opportunity to use the the rehydrated, but some companies will still use rehydration values to get you back to the ingredient statement, but it's all based on the math for pre-processed weight.
Okay. One of the questions here was, what type of palatant was used in the study? I'll go ahead and address that one. Within the PAL studies that we did, it was the same palatant on both kibbles normally, or else level would be changed. And the palatants that were used, I don't have the exact names of, but they were all commercial palatants that were utilized. And another thing that also, they were dry palatants that were utilized in the test. So similar between both, having the coating similar and also the palatant the same. Another one for you, Nathan, is how widespread is the high meat trend?
Well, I think that it's limited right now, but it's growing. And it's limited because many companies don't have the manufacturing capability to make those really high meat claims, right? The brands that do focus on really high meat, they have their own manufacturing systems. So they have invested highly into being able to reach those goals of the super high meat. But your typical average contract manufacturer probably can't get you to those ultra high end meats, because it pretty much takes a thermal twin screw, and there's not that many of those commercially available in the co-man space out there. Now, many brands I think would love to join the high meat club, but it's a limitation in terms of manufacturing capability.
And kind of relative to the manufacturing, one of the questions was, does the application work in a similar area with both types of extruders? And I can comment on that. When we first started testing in this kind of application to evaluate plasma, we started with the twin screw. However, as we were able to understand the application, and as you saw in today's presentation, we tested in both the single and the twin, and we were able to show similar responses and be able to work. They were independent of the extruder type and able to work in both situations.
Yeah, and I think, Joy, that I want to add, that was a good place to start, right? Because I think a lot of these companies want to get to the higher meat, and the vast majority of what's out there for contract manufacturing is going to be your single and twins. It's not going to be a thermal twin. So I think that this is the right approach to see where can we push a single and a twin, and even in some of the previous research we did, we got to a 45% meat, right? So I think, and not that we presented that information today, but we can push it, and there's still discussions about how can you push it higher, and what would the impact be if you put plasma into a thermal twin? That's another question that could be a potential study for future.
Yep, that relates to one of the other questions, is could it be done in higher meat extruders, such as what you just mentioned, than the thermal twin? And these are things we're wanting to continue to evaluate and look at in different types of extruders. Let's see, another question relative to was asking, do you have data on the density targets or tolerances for increased meat trials? In our studies, we were working with the Winger group, and the targets that we were hitting for densities there was ranging from about 450 to 500. Another question for you, Nathan, kind of a little bit what we were just talking about, is you refer to additives such as plasma to help emulsify. What levels have you used in this type of application?
Well, in the current studies, we've done 3.5 or 2.5 and 5, right? But I've used plasma in a starch-free kibble matrix, where there is no starch, and I know it can hold together a kibble with between 15 and 20% plasma added. So there's some opportunities there where you want to get really high in the animal-based protein claims. That's, starch-free is a way to get there.
Okay. One of the last questions again that's come in is, how do you recommend adding plasma for this application? As I said, we kind of did a series of experiments. We were first trying to figure out if the application worked, And then as we finalized and showed here with both the single and the twin, we formulated the plasma into the dry blend and least costed it. And that's how we would recommend kind of formulating into that dry blend and then doing your testing to see with the high meat application. With that, I think we've addressed the questions that had come in. We'd like to thank everybody for your time, for joining us today. And like I said, we'll be following up with I believe it's the link on the video of the webinar. So for that, I'd like to thank you for your time and appreciate you joining us today. Thank you.
Thanks, everyone.
Bye-bye.